Okay, so in this video I'm going to demonstrate the use of hash sets. I'm just going to create a new case, and I'm going to add a series of images to it, which are all of Linux systems which I've just created. So I've got three instances of Linux Mint with the Cinnamon, KDE and Mate desktops, as well as Ubuntu 12.10. And what I'm going to show is how we can create hash sets for each of these and then cross-compare the hashes from one set to another. And the hash set itself, once I've created it within Xvoice Forensics, I'll probably make available online, and people can just simply download it and point Xvoice Forensics at it, and then they can add further data to it if they want. All of these Linux systems were downloaded in January, so they're pretty recent, and they're basically just installed virtual machines. None of them have had any updates applied to, apart from the Ubuntu one, which I asked it to automatically update as it installed, but there's no additional software or user activity conducted on them. So we'll open each of these. Firstly, don't forget, when you're adding forensic images, if you find that it keeps going back to a different folder rather than to where you just left off, if you go into options, general options, and untick that box, it will not go to there every time. It will go to wherever you last added an image from. Okay, so we've opened the 4 images. We've got 4 tabs across the top, but we haven't yet opened the partitions. So we'll click on each of those, and each one will be traversed. With Linux systems, the traversing does seem to take a little bit longer, but I think that's because of the way that it deals with X2, 3 and 4 file systems, and the fact that once it's done the initial traverse, it goes back over it again to find additional bits and pieces, and it still only takes a matter of seconds to do most, which is quite mind-blowing really. So we do that for each one. While it's doing it, I'll just pause the video just to save on the size of the video. Okay, so all 4 partitions now have been traversed, and as you can see, there's numbers next to each one to indicate how much data it's found in this cursory glance of each partition, and all the tabs are open across the top. So what we can do now is create our hash sets either individually or en masse. I'll talk about that in a minute, but first things first, you have to create your hash database, which I have already covered in video 8, but I'll show again quickly here. We go to Tools, Hash Database, Manage. This is when you're first using it to create your hash database for the first time, which you'll add each of your sets to. So we go Manage. It asks you what kind of hash database you want to create. I tend to use SHA-1, but you could use MD5 or whatever you like. The important point is obviously the hash values to be added into the hash database have to match what the hash database is. So it's now created a quick skeleton database, the location of which, by the way, is specified here in the general options folder for internal hash database. So that can be on a shared network or wherever you like, but that's where it's actually stored, and that's where you'd need to copy it from if you wanted to move it. So at the minute it's all empty, and most of this is grayed out because there's nothing in the hash database. It's just created a raw set, a raw container effectively. So what we can do now, if I wanted to, I could, with no filters enabled, I could right click the case root, and show all the files for all of these forensic images in one go, I could highlight them all using Control A, right click, create hash set. So if these were all a particular set of evidence that you wanted to create a hash set for, that's how you would do it. But I want to do them one at a time. So for the Linux Mint 14 Cinnamon distribution, I'm going to right click that, explore recursively, list all the files. Now the point to note beforehand is that you obviously don't want to add things like your free space and some of the virtual files that Xbase creates into your hash set in an instance like this, where you're creating a hash set of a distribution or some kind of system. So you might want to filter those out first. As you can see down here, these are some of the ones listed. Now there's two ways you can go about doing that. You can either click on the name filter and in there type in the files that you want to see and then hide, or you could ask it not to show these by adding a colon before each one. So this is the equivalent of the not logic. So that should in theory show all files that aren't called that, which I think I've done wrong. Yeah, I'm not sure what I did last time, but there's the files in their entirety, which I could now, if I wanted to, hide file selects items and then have it not show hidden files so that they're then not hashed. But there's an easier way around it. Rather than doing that, I'll deactivate that filter. The easier way around it is when it comes to creating your hash set, when you right click create hash set, one of the options is only existing files. So you only want normal everyday files to be hashed and not all the virtual bits and pieces like free space. So in this particular instance, I'm creating distribution hash sets which I want to be considered to be system files. So I'm going to mark them as irrelevant, but the same would be true if you wanted them to stand out. You would obviously mark them as notable, and you can change them later anyway, but I'll just show you for the purposes of demonstration. So this is for the Linux Mint Cinnamon. It's only existing files. Click OK. So what it's now doing is creating a hash set based on the hash values of these files. But note that that's not yet computing the hash values for the actual case, and therefore not actually adding them to the volume snapshot, which is a separate step that we do at the end. This is purely for the purposes of creating our global set for use with Xbase Forensics. Because you might wonder, well, he's already hashing them, so why does he need to hash them again? They've been hashed for different purposes at this particular point. And what I'm going to do is repeat this step for each forensic image. So I'm going to right click and explore each forensic image, highlight them all and start creating the hash sets, but that's going to take a few minutes, so I'll pause it again. Okay, so coming up to the end of this process now. The fourth one is nearly had its hash values computed and added to the hash database. It's misleading how long this can take when you're running a fairly old machine with virtualization and what have you, but so it's nearly finished the last one. It does this integrity test to compare all the hash values within the database and things, and then when it's finished we should have a list of each individual thing. So as you can see, there's my hash set for Linux Mint Cinnamon, KDE, Mate and Ubuntu 12 is there, and they're all flagged as irrelevant. But if I wanted to toggle one of these to relevant, I could just click that button there, makes it go to notable, but again back to irrelevant. And so now we can use these in combination to do various things, and obviously the same system would apply if you were looking for specific sets of data for something else or for some other purpose. I'm using it in the context of creating system hash sets, but it's fairly unlimited as to how you can use this. So now we've got the hash database built. That's what I'll upload and put the link on the blog. But what we need to do now, of course, you'll notice over here there isn't currently any hash values listed for any files within the snapshot, and that's because I haven't asked Xways Forensics to do that yet. So far all I've done is built a hash database. So now what we need to do, from the case root, if we go specialist, refine volume snapshot, what we can ask it to do is compute the hash and match the hash against values in a hash database. And in this case, of course, we're going to ask it to do it for all forensic images, though I could just choose that one and that one, or that one, or that one, or all of them. Click OK to that, and then it will ask us what hash algorithm we want to use, but you can set it here as well if you want. So we're going to say SHA-1. So then it will now ask which hash database we want to do cross comparisons against. Well, I'm going to choose all, because what I want to show you in this video is how you can list files that appear on one computer and not another, or appear just in isolation or whatever. So obviously on each of these Linux distributions there are going to be files that are the same on each, and then there are going to be other files that are unique to that one system. So that's what I want to show you. So I'm going to choose all of them and click OK. So now what it's actually doing is hashing each file in the volume snapshot, and those hash values will appear next to each file along with their corresponding hash set once it finishes. But again, this will take a few minutes, probably 20 minutes or so for the whole case. So I'll pause the video and come back to it. Okay, so this is nearly finished now. It's coming up to the last few files of the last image. You can always tell where you are, remember, by looking at the message pane, which usually shows you what's going on. Okay, operation complete. So all the files are non-recursively hashed, as you can see across here in the hash column and hash set. You got some information there. And remember, of course, you can export recursively for all the forensic images. Here's our hash values. Here's the occurrence of those hashes in what sets. Now what Xways Forensics does, which is pretty cool, is if a hash value is found in multiple sets, then it shows you across here separated with a comma, which is the key point. It's all very well knowing that a file appears in a particular hash set, but if you don't know in what other hash sets it appears in, it's not so much use. So what you can now do is sort by the hash set column by clicking on it. It will say that it's sorting, and after a few seconds or minutes, depending on how much data you've got and how fast your machine is, it will sort all the files recursively in this instance by their appearance in the hash set. And so here, for example, you've got some files in there that are in the Ubuntu 12.10 hash, and then you've got some files here that are in the Ubuntu 12.10 hash set, and also in the Linux Mint 14.1 Cinnamon and Linux 14.1 Mate. And what you can do that's pretty nifty is obviously you can sort by this column, and any that are just in one particular hash set, then you know they're only in that image and not in other images. But what you can also do is, let's take this one as an example, which we know appears in multiple hash sets. We can right click that one and put a filter by its hash value, and that should show us other files that have that same hash value without actually having to sort by the hash column. And there they are. So here are the files, the only files that I'm showing you, but they're all the files with that same hash value, and there's their names. And lastly, what you can also do is, if we just deactivate that for a second and click on the filter funnel next to hash set, you can ask it to, for example, just show me the files from that hash set there, or files that aren't in that hash set by ticking that not box. If we just click activate for a second, yeah, and you could use any of these you wanted to just list that, and once you click activate, it will only show you those files. So that's it. Quick introduction to using custom hash sets with Xways Forensics.